Good evening, good afternoon, good morning, depending on the time you get to watch me. Welcome to another video on philosophical challenging ideas that I think everyone should know. Today, I want us to talk about logic. We want to discuss what is logic, the hidden structure beneath thinking. To start, I want you to think of a situation where two friends are in disagreement and you hear a statement like, you never listen, or the other person's talking about, you always do this. Also, think of a situation where a politician tells you, if you vote for me, I will lower the taxes. Or think of a situation you're watching TV and an advert comes on screen that says successful people always use this product. Or think of a situation where on social media there's a post that everyone keeps agreeing to. I want you to ask yourself a question. Do these agreements follow from the reasons given, or are people simply manipulating emotions, language, and assumption? That question leads us to one of the most powerful disciplines ever developed. That discipline is logic. We start off by defining logic. Logic is the study of correct reasoning. When we say correct reasoning, it means there is incorrect reasoning. So I want you to ask yourself how you reason. Do you reason correctly or incorrectly? In logic, we ask, does the conclusion follow from the evidence, the facts, or are there assumptions that are sneaking in? In logic, we are interested in distinction between good and bad reasoning. We are interested to avoid contradiction, confusion, misinformation, and manipulation. So in this case, logic is not just merely about being intelligent. A highly intelligent person can still reason badly. In fact, I think you have witnessed situations where very intelligent people, very learned people who reason badly. So logic in itself, it disciplines the thinking itself to be sure that we are always trying to reason correctly. For us to reason or to think or to do logic, we use communication. In our communication, we use sentences. There are many types of sentences. Some sentences just command, others give instructions, others just make exclamation. But the most important sentence in communication is called a statement. A statement is similar to what we record at the police station. That statement, the reason why you record a statement is because when that statement is interrogated, either in judicial court, it can be determined to be true or false. If it's true, it's then adduced as evidence in court. If it's false, then it's thrown out. Similarly, in reasoning, we use statement. A statement is a claim that can be determined to be true or false. Therefore, if someone is speaking and is using a sentence that you cannot determine to be true or false, then you're not engaging in logic. A statement, an example of a statement, is something like, the earth orbits the sun. That is something that we can determine whether to be true or false. You can also say water boils at 100 degrees Celsius. That's also a statement. We can determine it to be true or false. Another statement is something like, all humans are mortal. That sentence can also be determined to be true or false. It is statements that will come together to form an argument. So when you're making an argument, you need to use statements that can be determined to be true or false. And when those statements are arranged in a certain relationship that forms a good structure, then we are engaging in logic. An argument therefore, is the next most important concept in logic that we need to know. An argument contains two things: a premise and a conclusion. You can have many premises and only one conclusion in an argument. A premise or premises are the reasons that are being made in an argument, and the conclusion is the claim those reasons are supposed to prove or to support. So to make an argument is to lay out your premises in such a way that they have a relationship that leads you to a conclusion. Then you have made an argument. Now, I want you to ask yourself, whenever you usually say, listen to my argument, do you usually follow similar structure? Or what do you usually mean when you say, listen to my argument, or here is my argument? Do you follow that kind of structure? Here is a simple example of an argument. All humans are mortal. Nyongesa is human. Therefore, Nyongesa is mortal. That is an argument. There are two statements or two premises. All humans are mortal. Nyongesa is human. Those are premises. Therefore, Nyongesa is mortal is the conclusion. So the two premises lead us to the conclusion, and that is an argument. The last statement can be the first, but basically one of the statements in an argument has to be the conclusion, and the premises has to lead us or give us reason, relationship, or structure that makes that conclusion to be the claim that's being made. There are three types of arguments. In other words, when we are doing logic, which is technically reasoning, we reason in three ways. And I'm going to talk about those three ways of reasoning. And so we shall start off with deductive logic or deductive reasoning. Now notice something important. If the premises will connect well, the conclusion must follow from the premises. When you have a situation where the two premises having a good structure and relationship forces you to have to accept the conclusion, that's called deductive reasoning. In deductive reasoning, we move from the general principle to the necessary conclusion. For example, we can go back to the argument that we had earlier. All humans are mortal. That is the general principle. Nyongesa is human. That is a claim being made. Therefore, Nyongesa is mortal. Given the first two premises, all humans are mortal. Nyongesa is human. The necessary conclusion is Nyongesa is mortal. That is a deductive argument. The premises lead you to the conclusion automatically. It cannot be otherwise. When we are reasoning from deductive method, there are two ways to assess whether we are reasoning correctly. The first way of assessing deductive reasoning is called validity test. In validity test, we ask ourselves, number one, does the premises lead us to conclusion as a matter of logical necessity? If that is the case, then that argument is valid. So, a deductive argument can be valid or invalid. In the situation where the premises do not lead us to the conclusion as a matter of logical necessity or automatically, then the argument is invalid. For example, the valid argument is Here's the valid argument. All humans are mortal. Nyongesa is a human. Therefore, Nyongesa is mortal. That is a valid argument. The premises lead us to the conclusion automatically. It cannot be any other way. But listen to this one. All humans are mortal. Nyongesa is a runner. Therefore, Nyongesa is intelligent. That is an argument in the structure of a deductive reasoning, but the premises do not lead us to the conclusion. There is no connection between all humans being mortal, Nyongesa being a runner, and the conclusion, therefore, Nyongesa is intelligent. There is no automatical connection, and that argument, therefore, is considered to be invalid. A valid argument means the conclusion logically follows from the premises. But validity alone is not enough. You cannot have a valid argument, or rather you can have a valid argument built on false premises. For example, all cats are bad. Tom is a cat. Therefore, Tom is a bird. You can see that that is a deductive argument, but that deductive argument is made up of premises that have a problem. The structure is logically valid. All cats are birds. We can agree, if we assume that is to be true, then Tom is a cat, therefore Tom is a bird. That follows from the structure. The conclusion that Tom is a bird follows from the structure. But those premises, all cats are birds, have a problem. They are false. Tom is a cat is false. Therefore, even though the conclusion follows from the premises, this argument has a problem of falsehood. And in this case, the argument is assumed, or it's determined to be unsound. So there's a characteristic of deductive logic called soundness that's really important. So philosophers make distinction in deductive argument of sound and unsound. A sound argument is both valid in structure. For example, all humans are mortal. Nyongesa is human. Therefore, Nyongesa is mortal. That argument is valid. The premises are also true. And so, this argument is determined to be sound. But if we go to the argument that was all cats are birds, Tom is a cat, therefore Tom is a bird, that argument was invalid. And because it's invalid, that argument is unsound. It's unsound even though the structure or the relationship in the premises are okay. So, when you're looking at deductive logic or deductive reasoning, you have to identify whether the argument is valid or invalid. So when you hear someone saying the argument is valid, you need to ask yourself, what do they mean by validity of the argument or invalid? And also, once the argument is valid, the next test in reasoning is whether the argument is sound, because we are interested to know whether the premises in the argument are actually true. You could have a valid argument that is also unsound. The second way of reasoning is called inductive reasoning. In inductive reasoning, we will realize that not all reasoning gives certainty the way deductive gave us certainty. It was very clear in deductive reasoning that if the premises have good relationship and structure, they lead us to conclusion as a matter of necessity. In inductive reasoning, it's different. So for example, suppose you observe the sun has risen every morning of your life, and then you conclude the sun will rise tomorrow. In this case, you're using accumulation of evidence of day 1, day 2, day 3, and concluding that because the sun has kept on rising since you're born, and now you're 20, you assume the sun will rise tomorrow. That kind of reasoning that's based on looking at evidence and accumulating them and putting together the patterns and assuming or generalizing is called inductive reasoning. We reason from specific to the general. It's not the same as deductive reasoning, where we reason from the general to specific. Now, in this case, where we reason from the specific to the general, we look at the sun rises today, it rises next week, next month, year 1, 100 years, and then we conclude that the sun will keep rising. We are using specific evidence to make a general conclusion. But we cannot be so sure that the sun will rise tomorrow. Therefore, that conclusion that the sun will rise tomorrow is not guaranteed. It's just highly probable. So in inductive reasoning, which is based on specific evidence, specific facts, specific observation, it does not give us foolproof conclusion on anything. It only gives us a situation that's highly likely, a situation that is highly probable, but not a conclusive in the same sense as deductive reasoning. So when you are reasoning through induction, you need to be careful because the induction does not give us a foolproof knowledge on anything. Science research uses inductive reasoning, where we collect evidence of something happening today, tomorrow, and then we try to generalize. What we get from that is inductive reasoning. It's not conclusive, it's likely, it's highly likely. So if you hear scientists talk about their research finding, they will always say something like, given the factors or given conditions being what we observed, the situation is likely to remain this way. They are hesitant to be conclusive because things might change. So induction reasoning does not give us foolproof knowledge. So when we assess inductive reasoning, we are interested to know whether it is strong or weak. A strong inductive argument gives you good probability to support the conclusion. A weak inductive argument gives you very low probability to support the conclusion. And therefore, all weak inductive arguments are bad argument. When an argument is weak and inductive, it automatically becomes uncongent. And congency is another way of testing an argument that is inductive. So if you have a strong inductive argument where all premises are also true, then you have a congent argument. A congent argument is one where the premises are so strong they give you a conclusion that is highly likely or has high probability. And if the premises are also true, then that is a congent argument. However, if it lacks a strong support or true premises, that inductive argument becomes uncongent. Then we have another third way of reasoning called abductive reasoning. In the abductive reasoning, which we constantly use generally, abductive reason asks what is the best explanation. It does not follow structure like deductive argument or inductive. It's only interested in finding what is the best explanation. You use very few facts, including just one fact, to make a conclusion. So for example, you wake up in the morning, You look outside the window, you see outside is wet. You conclude quickly, based on wetness, that it rained. Or you look up the sky, you see it's cloudy, and you decide it might rain. You carry an umbrella. That kind of reasoning is called abductive reasoning. So in other words, we have three ways of reasoning. We have deductive reasoning, inductive reasoning, and abductive reasoning. When you're reasoning, I want you to ask yourself, which method of reasoning do you usually use? Is it abductive, that uses very few evidence and then you make a major conclusion? Or is it deductive reasoning, which is foolproof? It's almost like a straight channel. Whatever the premises give you, that leads you to the conclusion. Or is it inductive reasoning, where one of the greatest inventions for human mind was to be able to put things into groups? We studied this in high school. We called it taxonomy or classification, where we look at things that exist and try to put them into group. To some extent, if you think about it, all the kind of studies that we do is usually to identify things that exist and then try to fit them into a group and see what kind of relationship and structures do those things have together. So when we are studying, or when we are thinking about things in groups, we do what's called categorical logic. This is the logic where we look at things that are in groups and then try to talk about their relationships. For example, we have a group of things that we call humans, and we have things that we also refer to as mortals. So the things that are humans could be female, male, children, old, women, men, or anything that we can consider to be human. That's a group of things. Then we have things that we call mortals, things that die. And then we can talk about the two groups. So for example, we can say that all humans are mortals. In other words, the things that are human belong to the group that is mortal. We can also talk about birds, and we can say we can have things that we call birds in one group, and then we can have things that can fly and say all birds belong to the groups of the things that can fly. We can also talk about shapes, and we can say something like no squares are circles. This kind of conversation or reasoning is called categorical reasoning or categorical logic. And the statements, all humans are mortal, some birds cannot fly, or no squares are circles, that is categorical proposition, because they describe the relationship between the categories of things. Why is this important? It's important because categorical logic is fundamental to philosophy, mathematics, and scientific classification. Categorical logic trains the mind to think clearly about relationships and structure. Logic is really important. It's the foundation behind most of the things that we really pride ourselves in. For example, science. Logic quietly underpins every serious aspect of science. Researchers form hypotheses, they test evidence, they collect data, they are able to analyze that data and draw conclusion. That process is a process of logic. It's an improvement on the logic that we're talking about: deduction, induction, abduction. And so you can see that scientific enterprise relies on logic. Without logic, science is not possible. Logic is the foundation of science. Science constantly combines induction and deduction to be able to do its work. The progress we've been able to make in science is thanks to logic. Logic is also relevant in law, and debate. In law, we are interested in evidence. Evidence must logically support the conclusion, what is called the verdict. When a lawyer presents an emotional story, the logic or the magistrate will always ask, do the premises actually justify the conclusion that the advocate or a lawyer is asking for? If a prosecutor also presents his evidence, the magistrate will always ask, do the premises support the conclusion that the prosecutor is asking for? And so in that sense, you can see that logic is foundational to law and even debate. Logic is also useful just in our ordinary life. In ordinary life, logic matters constantly. Suppose someone says, you always do this. You have to ask yourself, based on what evidence? And there you are engaging in logic. When someone says always, then you need the evidence to support the always conclusion. So logic protects us from exaggeration, manipulation, and unfair reasoning. In media, advertising, and politics, advertisement always manipulates desire instead of proving reason. Political rhetoric often manipulates fear instead of giving evidence. And so, we want citizens to be armed with logic, to be able to discern what the advertisement is saying, to be able to analyze what politicians are saying, so that we are not manipulated, we can detect exaggeration, and we can protect ourselves from misinformation. So logic teaches you to ask, what exactly is the argument? It also teaches you to ask, what kind of assumptions are hidden in these utterances? It also teaches you to ask, does the conclusion follow from the evidence that have been given? You cannot be an analytical thinker or critical thinker if you do not understand logic, because you need logic for you to do analysis. You need logic for you to be critical. This is why logic sits at the center or at the heart of analytical and critical thinking. Logic plus evidence produces better judgment. It helps human beings resist misinformation, propaganda, and emotional manipulation. In our time, especially this time of artificial intelligence, viral information, and political polarization, logic is very, very important. Logic does not tell you what to desire or what you should like, but it does tell you something that can protect your mind from being manipulated. It does not tell you what is moral or what is immoral, but it teaches you to look at things and be able to judge them and see which fits in the category of moral or immoral. Logic teaches you to discipline your mind, not to jump to conclusion, to always check evidence, and to avoid making conclusion using rushed assumption. It forces thinking to become accountable to structures. Our civilization was built on language, but civilization survives through reasoning. When you have a society that is not reasoning properly, you realize that their politics is always in chaos, they cannot manage their economy, and people's lives struggle. So logic gives us an attempt to try and reason in a reliable way. So in that sense, to study logic is to learn how to be easily not deceived, including deceiving yourself. The easiest person to deceive is you But with logic, you are able to resist not only being deceived by other people, but by also deceiving yourself. I hope you've learned something. We started by defining logic. We talked about the different types of logic: inductive, deductive, abduction. We talked about categorical logic, and we've talked about the various ways that logic supports different disciplines. And now you have learned something on philosophical challenging ideas that I think everyone should know. Leave a comment and tell me what you want me to discuss next.